Okay, so we're starting on 2, is this D as in donkey? Okay, 2D. And this is off of worksheet 5.1, worksheet 6. All right, so here is how you would start this problem. First of all, you either want to get things to cancel, or if you can't do that, get them all to be the same function. See how I got a sine and I got one cosine? That cosine there, I'm thinking I should change that. Thinking I should change that to a sine. Because if I can, if they're all the same function, then I can factor. But I can't really get this thing all to be one function until I get that cosine changed. And then I can factor it after it's all one function. Okay, so how do I get this fixed? Well, I got to go back to what's the fact I know about this. Cosine squared plus sine squared equals 1. And I've got to use that somehow and get cosine alone so that I can see what cosine is equal to. So I put this over to the other side, 1 minus sine squared theta, and I get that off of there. So now I know that cosine is 1 minus sine squared theta. So I can go over here and put in 1 minus sine squared theta. Then, it's a new problem. That's all got one function in it. I should get it all to one side and set it equal to 0. Why? Because I want to get it all factored down and look like this. To do that, turn around please. To do that, I want to get this side equal to 0. So I got to get all that stuff over to here onto the other side. All right, so next up, I'm going to add, or no, subtract 1 from both sides. That'll get that 1 to come over to the other side. Sine squared theta minus sine theta. And now the 1 comes over and it's minus 1. And then negative sine squared comes over and it's plus sine squared theta equals 0. Now I've got it set equal to 0, and it's all one function. Now I just have to like simplify it down and factor it if I can. A sine squared and another sine squared go together and make 2 sine squared thetas. 2 sine squared theta minus sine theta minus 1 equals 0. Notice I have something squared. I have something not squared. And I have a number that's telling me, please factor me. So I'm going to factor this out. Now I like to do this. You don't have to, but I like to. You're going to get the sign swapped out for just an x. Instead of sine theta, we're going to put an x. So technically I should say, let sine theta equal x. That'll allow me to factor this in a little cleaner form. So, what is it going to be? 2x and x has to be that. Next thing, I have to have a negative 1 and a positive 1 to make a 1. And then I just got to see if this will actually work. That makes positive 2x. That makes minus 1x. Nope, that one is going to give me positive x as a middle term. I want negative x. Whenever you get the exact opposite of what you want, you switch the signs. So this 9 goes from a minus to a plus. And that sign goes from a plus to a minus. And now it's factored. Okay, so I factored it. And if factoring is your issue, then you got a whole bigger issue because you got to know how to factor. That should be like the easy part. Okay, now that I've done that, now I got to swap it back out. Remember how I said sine of theta is like x? So then wherever I see an x, I got to put it back in a sine theta. So 2 sine theta. So what I'm doing is this x right here. I'm putting in sine theta right there. 2 sine theta plus 1 has to equal 0. I set this side equal to 0 and this side equal to 0. The other side is sine theta is minus 1 is equal to 0. Then I'd go 2 sine theta equals negative 1. Divide by 2 on both sides. So sine theta is equal to negative a half. And now I can get a couple answers for that. Where is sine negative? All students take calc sines positive here and here, so it can't be there. Sine has to be negative. So it has to be down here and over here. And from there, you ought to be able to handle this. That stuff we've already tested on, and that's got to be the easy part. Another one of the easy parts. And if it's find all solutions, thank you. If it's find all solutions and I come up with an answer that's, let's say, let me see this quick. It's got to be pi over 6, but then it's actually 7 pi over 6 is this one. For instance, 7 pi over 6 is one of your answers. Then you go plus and minus 2 pi n. That's how you say all solutions, because you can keep going around and around and around the circle, and that's 2 pi to go around the circle, and keep getting new answers that will work. All right, so that's one of your answers. The other one is this one. If this is really pi over 6, then this should be 11 pi over 6. Hold on a second, please. I'm not done yet. Because these are two of my answers. Plus minus 2 pi n. This one needs a couple answers too. So sine theta equals 1. And then that must be a quadrantal. Please don't talk right now. And after I know that's a quadrantal, I'm going to say where is y over r? Where is y1? Y is 1 right there, and therefore it's pi over 2. And the same deal, since it's all solutions, plus and minus 2 pi n. There we go. That's all of the answers for that question. Okay, now do you have a question, clarifying question? Good, yes. Okay, this triangle in the third quadrant, the red one, right, I just drew right there? Okay, so first of all, opposite over hypotenuse. Opposite's 1, hypotenuse is 2, and this must be square root of 3, and one of them has got to be negative, and that's this one. Well, actually, two of them are negative, but in this case, the sign has to be negative, right? So we knew one of them was going to be negative. All right, now, do you know which one's across from the 1? That's the 30-degree angle, also known as pi over 6. But you really need this one. You need the one that goes all the way around here, from here all the way to there. And that is 6 pi over 6 gets you to here, and then 1 extra pi over 6 makes a total of 7 pi over 6. Hold on. Okay. Nope. If you were doing, that's tangent. Okay. Sine is opposite and hypotenuse. Only one of them is negative, so we're okay. All right. All right, that was one. Tough one. You may remember that I told you that it might be smart to do these on a separate sheet of paper because it'd be hard to get all of that on the little worksheet space. Okay, want to see another one? Ask if you want to see another one. Yes. B as in boy? All right, 1B. No. 1A got crossed out and 2B as in boy got crossed out. But 1B is still alive. All right, so if we're going to do that one, 2 cosine, first thought is you better get it to be all one function. Cotangent. So how do I get it to be all one function? Got to substitute something. Maybe change cotangent into, what would cotangent be? Cosine over sine. And that won't fix it though. Interesting. Nope, 1B was not crossed off. It was 1A and 2B were crossed off. All right, I'm thinking, just because I haven't figured it out in 2 seconds doesn't mean it's impossible. Give me some time. Question on this? Yes, we can change. All right, I'll be trying. Cosine theta, and you want to change this to cosine over sine. I agree we can do that. Now, tell me why that helps. I do have a cosine squared then. Okay, is that what you're saying? You're right. How about this? We could change cosine into what is cosine again? 1 minus sine squared? Could do that. Then we got it all into sines. So change this into 1 minus sine squared? Or does somebody have a better way to do it? Because sometimes there's a really cool way that I don't see at all. Right now I'm only thinking get them all to one function. All right, then I'm going to try that. 2, and then I'm putting in there 1 minus sine squared all over sine minus 3 equals 0. I could factor this, and I don't know if it'll help me at all, but it's good for you to notice that that's a difference of squares. So therefore I could factor into 1 minus sign and 1 plus sign. But I don't think that helps. All right. So, I've got an idea. All right. Anytime you've got two separate fractions, it's a good idea to try to put them together. I know this doesn't look like two separate fractions, but it really is. There's this, and there's this. What if we could make that one have a denominator of sine? That way I could actually add it together. And then I can put that 3 up with that other stuff, and maybe something will cancel. All right, so I'm going to try that. I am going to multiply this by sine over sine. Do you mean multiply the whole thing? Oh, that's an interesting thought. Multiply the whole thing, like not just the blue and red stuff. Multiply everything by sine theta. Good idea. Sine theta and sine theta. Good idea. Okay, because that'll cancel this, and then this will be 3 sine theta, and this will be 0 again. So 3 sine theta, and this is negative. And then this on the top will be 2 times 1 minus sine squared theta. Okay. Now I can actually multiply that all out. And 2 times the 1 makes 2, and 2 times the negative is negative 2 sine squared theta minus 3 sine theta equals 0. And then let's move that to the front. Negative 2 sine squared theta minus 3 sine theta. Oh yeah, this thing's going to factor. Minus 2 equals 0. No, plus 2. Sorry. All I did is rearrange it there. This went here. And then this moved over a notch. And then the 2 that was up in the front is now at the end. Okay, now here's a trick that is really handy. Are you doing math on that iPad? Yes. Okay, good. Then I'm good. Okay, stay with me. All right. This negative here, if you ever are trying to factor something with a negative in front, just don't do it. Multiply by negative 1 here, and here, and here, and there. Every place gets multiplied by negative 1, and that's okay. It's legal to do that. So then I got 2 sine squared theta. It's not negative anymore. And that's a plus 3 sine theta, and a minus 2 equals 0. And I betcha, as I change this to an x squared, 2x squared, plus 3x minus 2, I'm doing that substitution. It's called a u substitution. In fact, they always use u's in calc. Maybe I should use u. It can be any letter you want it to be. They say let u equals sine theta. And then you'll learn that if you go on to AP or regular calc, they do u substitutions. All right, so now I got to factor this out. So we go and 2u and u, and then this has got to be a minus 2 and a plus 2. Let's try it this way, or 1. So let's see if outside and inside, does that work? No, that didn't work. So I got to move the numbers around. Plus 2 and a minus 1, you think? Okay, I'll move that. So I'm trying to factor 2u plus, what? Minus 1, and then plus 2, thank you. Okay, so let me check that. Outside, inside, positive 4 minus 1 makes positive 3. And the last, yes, it worked. Yay. So now, I finally got it to the point where I now know that the u is sine of theta. So I'm saying 2 sine theta minus 1 has to equal 0, because this whole side has to equal 0. And over here, sine theta plus 2 has to equal 0. And then I solve this side, which looking like it's going to come down to a half again. Sine theta equals half, and this side's going to be sine theta equals negative 2. And oh, cool, at least one of the sides is impossible. That's good, because that means this is out. And that leaves just this one, and I had to memorize that one, because it comes up a lot. Remember me saying that? Pi over 6, also known as 30 degrees. And then if it's pi over 6, it's also 5 pi over 6. There we go. And was this an all solutions one? Okay, then these are the two answers. It's just from 0 to 2 pi. All right. Yeah, the undefined ones are, there's no point in finding them if they don't really work. Okay, the reason, again, this one didn't work over here was because we had opposite over hypotenuse, and the hypotenuse is way smaller than the hypotenuse, than the Hypotenuse is smaller than the other side, and that's not possible. So we knew that was out. Whew. Hypotenuse will always be the biggest side, or if they're equal, then you're at one of the quadrantals. Okay, anyway, to go back to what we did on this, we figured out that we had to get it down to only one function. And then another moment that somebody had in the crowd was that you had to multiply by sine, and that was a really good idea. And that got rid of our fraction problem. Anytime you have a denominator that you want to get rid of, just multiply by that denominator all the way through. And then when we were all done simplifying it, it came out to a quadratic, something squared, something not squared, and then a number. And that meant we could factor it. Once we got it factored, then we got it down to solving for an angle. And it comes down to a statement like this, which would have been the problem on one of your previous tests. That it takes like half an hour to get there. And then you actually get your two angles. That's R3. What would an R2? I know what you mean. This one was just especially tough because you had like several steps in it to get there. So it wasn't like an impossible R3. It was an R3. Especially nice R3 because we only had to do one side. The other side was just undefined and it was done. Okay, I know these are tough. But again, you have to you have to decide if when the going gets tough, you're deciding it's nap time, or when the going gets tough, you're going to buckle down. You can complain about it, but buckle down and try to figure them out because they're doable. All right.